So today we will discuss law of equipartition of energy, right? लिखो law of equipartition of energy, equipartition of energy. So in this law it states that if a system is in thermal equilibrium, then the total energy is distributed equally in all the degrees of freedom. Degrees of freedom means that is all energy groups, right? So if a molecule is in random motion in a gas, then it will have three types of motion. What are those three types of motion? Translational, rotational, and vibrational. So you know, suppose there is a monoatomic like जैसे argon, helium. So monoatomic gas means what? That will have a single degree of freedom, that is single axis. It can, the motion of the gas molecules can be represented by a single axis, that is one dimensional, or we can tell that is your translational motion only, right? If there is a diatomic molecule, diatomic means what? There will be the axis containing these two atoms, so that can also rotate. So in this case, addition to this translational motion, we will also have the rotational motion, right? So diatomic molecules, they may be of two types. One will be rigid, another one will be not rigid or free. So if rigid, then what will happen? It will remain, the axis will remain in one axis, so it can rotate in other two axes, right? So rotational, that motion is possible along two axes if that is rigid. If that is not rigid, then the axis can rotate in either directions. So you know, the motion of a particle can be represented by three axes. So rotational motion will be 3 if that is not rigid. Similarly, some molecules will have the vibrational motions, and vibrational motions means that will oscillates along a particular line that is joining the axis, right? So vibration means it will occur at a particular temperature. In normal temperature, normally vibrational motion does not occur, but if the temperature increases, then the molecules start vibrating. So similarly, the vibration energy will also be there, right? So law of equipartition of energy states that all the energy in thermal equilibrium, all the energy that is distributed along each degrees of freedom equally, and that is equal to half kBT, right? That is half kBT. So this is your law of equipartition of energy. Clear? So what it states? Write down. It states that in thermal equilibrium, the total energy is distributed equally in all the degrees of freedom which is equal to half kB capital T half kBT, half kBT. So this is understood. So now we can find out the total average kinetic energy of a molecule if that is monoatomic or diatomic or triatomic or polyatomic, right? So it will have three possibilities, either translational or rotational or vibrational. Vibrational is not in a normal concept. If the temperature increases, then only that will have the vibrational motion. Otherwise, there is the possibility it will have translational also or rotational also, right? So we will discuss one by one. Then what will be the total energy, and in that we have to find out Cp, that is the specific heat capacity of a gas at constant pressure, then specific heat capacity at constant volume, then we can find out the Cp upon Cv, that is a ratio that we can find out. So by this, so for monoatomic gas, right, for monoatomic gas, for monoatomic gas, what is the degrees of freedom? For monoatomic gas, it will have only translational motion. Will have only translational motion. So what will be the degrees of freedom? The number of degrees of freedom will be only 3. Only 3. Right? So this was the energy for one molecule. So if we want to find out the energy of 1 mole of a molecule, so you can write average kinetic energy of 1 mole will be equal to half kBt into Na, that is Avogadro number. So you know this Boltzmann constant into Avogadro number, this is equal to universal gas constant, that is R. So this will come as half RT, and this is per degree of freedom. This is per degree of freedom, right? So what will be the total energy of 1 mole of a molecules which is monoatomic? So total average kinetic energy will be number of degrees of freedom, that is F, into this is your half RT. So this will be equal to your 3/2 RT. Right? So what will be your Cv? Molar specific heat capacity at constant volume.